In this video, we want to look at the problem where we need to find a degree 3 polynomial with zeros 1 and 3 minus I. So the first thing when you look at this problem is, we know we want a degree 3 polynomial, but you may be saying to yourself, if we have a degree 3 polynomial, then we should have 3 zeros. And if that's what you're thinking, you're definitely on the right track. The other thing to notice is one of the two zeros that we're given is a complex zero. We're given 3 minus I. And that's going to be kind of a key to look for in a problem like this, where it doesn't look like you're given enough information. Anytime you're given a complex zero, you'll always know that its complex conjugate, in this case 3 plus I, is also going to be a zero. So even though it doesn't list it, you want to keep that in mind and you want to include it when we create our polynomial. So what we're going to do is we're going to go ahead and we're going to turn these zeros into factors, and then we're going to try to write out what this polynomial will be. So we can call it f of x, or you can call it whatever you want to. And we're going to go ahead and turn each of these zeros into factors. And so to turn a zero into a factor, you just want to say x minus whatever that zero is. So this 1 is going to turn into x minus 1. The 3 minus I is going to turn into x minus 3 minus I. But we want to write that as x minus, and then we want to open a set of parentheses and then do the 3 minus I. And the reason for that is we want that negative to be applied to both of those terms. So definitely don't forget that. So that's going to be the second factor from the zero we're given. We're also going to write a factor for the zero that we inferred. And if there is going to be one complex zero, we know there has to be another one balancing it out, because ultimately we want all of those i's to go away so we actually have a real polynomial, or a real coefficiented polynomial. So we're going to do the same thing, x minus parentheses 3 plus I. And there essentially is our polynomial. Now, if you need to leave it in factored form, you could go ahead and put an a out front, because we're going to have some kind of constant that goes out front. And really there's an infinite number of polynomials that have these zeros, just they could all be multiplied by some constant. And so that's why we put the a there, because really, like I said, there's an infinite family of polynomials that meet these conditions. But you may want to multiply this out depending on the type of problem you're looking at. You may not need to leave it in factored form. So if that's the case, then we're going to just multiply everything out. We're going to go ahead and rewrite the x minus 1. And before we FOIL and FOIL again, I'm going to go ahead and distribute the negative in both cases of our second two factors. And so that's going to give us x minus 3 plus I in our second factor. And the third factor is going to be x minus 3 minus I from distributing that negative. Again, we'll throw the a on once we get done. Now we can go ahead and we can FOIL this out in whatever order we want to. What I'm going to do is I'm going to go ahead and multiply the second two factors together. So we're going to get x squared minus 3x. Let's go ahead and rewrite our x minus 1. X squared minus 3x. And then we'll get minus xi minus 3x. So minus xi minus another 3x. And then we'll do plus 9 plus 3i plus 9 plus 3i. So you can see some of these i's are canceling out already. And the last thing to do is multiply the I by all the terms. Plus xi minus 3i plus xi minus 3i. And then finally, minus I squared. So that's from FOILing all of that out. So if you did everything right up until this point, and you multiplied out the factors the way I did, the ones with i's first, then all of the terms with i's, just an I to the first power, should cancel out. So we can check ourselves, minus xi plus xi, plus 3i minus 3i. Also, another thing is, anytime we have an I squared, we can put negative 1 in its place. So we're going to replace that I squared with negative 1. So now let's rewrite what we have. So again, just bring down the x minus 1, and we'll have x squared. Now we have a couple of like terms we can combine. We have minus 3x, another minus 3x. That's going to be minus 6x. So we'll go ahead and write that. And then we have our positive 9 right here. And then we're going to have a negative and a negative multiplied together, giving us a positive 1 there. So we'll have 9 plus 1 gives us 10. So we'll go ahead and write plus 10 right there. And so now all we have to do is multiply again. We're going to multiply the x minus 1 by the x squared minus 6x plus 10. So again, just kind of foiling this out, or multiplying each term by every other term, we're going to get x to the 3 minus 6x squared. So x3 minus 6x squared. And then we'll get 10x minus x squared. So plus 10x minus x squared. And then we'll have negative 1 times negative 6x is going to be plus 6x minus 10. So plus 6x minus 10. And I'm putting this all in parentheses because, again, we want to keep in mind that we need to have some sort of constant or coefficient out in front, because that could be absolutely anything. It could be any number that we wanted to multiply, and we would still have the same zeros. In other words, meet the same conditions. So let's go ahead and combine any like terms that we can. Keeping the a out front, we'll have an x to the 3. We have minus 6x squared minus another x squared, so that's going to be minus 7x squared. And now looking at our linear terms, we have plus 10x plus 6 more x, that's going to be plus 16x. And then finally the constant terms, we just have the negative 10. And so we'll throw a negative 10 on the end. And so that is going to be our answer. F of x is going to be equal to some a, whatever it is, multiplied by x to the 3 minus 7x squared plus 16x minus 10.